In this video, we are looking at problem 7-9, where we are going to calculate the standard deviation of a two-asset portfolio. So we have two stocks, stock A and stock B, and we're looking at the weights. We need to know the weights of each stock, so they're giving us the weight of stock A. So what this means is that 30% of the total investment is invested in stock A, and the remainder is in stock B, so that's got to be 70% in stock B. And there's an expected return of 21% with stock A, and with a standard deviation of 5% on that return, and an expected return of 18% on stock B with a standard deviation of 2%. Now, when we look at the formula, you can see that we really don't need expected return. We just need the weights, the standard deviation of both of the returns on both of the assets, and we need the correlation coefficient, which is the R value of the returns of asset A and B, which is given in the problem is below 1.06. So I wanted to talk a little bit about the correlation coefficient. I think you know what the weights are and the standard deviation of the returns. That's just how much. When we think about this, the expected return is 21%. So that's the weighted average. They figured that out by looking at a series of possible returns, just like we looked at a series of possible sales right here, and figured out the expected value of a the expected value of a probability distribution. So that's what they did with the return. So they probably had a series of expected returns and calculated that the mean or the expected return was 21% with a standard deviation of 5%. So if you think about it like that, then that means that there's less of a deviation in the probable or possible returns for stock B than for stock A. But for the purposes of this problem, we just need to know what these are so we can use them in the formula. Okay, so back to the correlation coefficient, or the R value. Now, what I've done here, once again, is I've got two tables that we can work with. A top one is for you to put any numbers or values in you want and just see what happens. So we're going to look at that, and then for the bottom one, this is where I want you to put the values in for the actual problem. So for example, for stock A, you would put a weight right here of 30 or 0.3. So if you put 0.3 right here, it's going to convert. Sorry about that. It's going to convert to 30%, right? So that's how that's going to work. Let me clear that out so you guys can do this. But I wanted to show you. I wanted to talk about this idea of the R value. And if you go on page 147 of your book, right here is a pretty good general summary of what the R value is. So it's a value between -1 and 1, and the closer it is to 1, this means that the expected returns on these two stocks correlate. So they're going to move in the same direction. If one goes up, the other one is likely to go up, and if the other goes down, the other one is likely to go down. If it's closer to -1, then the two variables tend to move in the opposite direction. So if one goes up, the other is going to go down. And if it's 0 or near 0, it means that there's no correlation at all, so they're not related. So one could go up and the other one could go up, or the other one could go down. They're not really, there's no relationship between one one stock's movement or the returns and the others. And this is called statistical independence. So if we go back to our problem, I've got this note right here copied into it, so I'll just go back there. And if we read this, it says that anytime the correlation coefficient of the returns of two assets is less than 1, then the standard deviation of the portfolio consisting of those assets will be less than the weighted average of the individual asset standard deviation. Okay, wow, a lot of words there. What they're saying is that if the R value, if they don't really correlate, then the standard deviation, then the actual deviation is going to be less than the weighted average. So I've put some numbers in here. I just randomly put in two weights, and I've made these even. They're not actually random because I made them even on purpose so that we can look at the really easily calculate the standard deviation. We can see, we can look at the weighted average of the individual assets standard deviation. So if they're both weighted the same and one's standard deviation is 8 and the other is 2, then the weighted average here is going to be that they're both going to have the same weight. So that means that the average is just simply the midpoint between 8% and 2%, which is 5%. And we can see with a correlation coefficient of less than 1, then the standard deviation for the portfolio is less than the average here, less than 5, it's 4.49. Now, it's easier to sort of see how this works if we put this at 1. We'll put the correlation coefficient or R value at 1, and we'll see that now it is 5. Why is that? Well, if they both exactly correlate, that means that the standard deviation of both of them moving are of both of these combined is going to be exactly the average of what they are separately. If they both totally correlate in their movement. If they don't correlate at all, so if we put a 0 in here, then we can see that it's much lower than the average. And just for the fun of it, let's see what happens if we put in a -1. So that's 4.12 with 0. Let's see what happens if we put in a -1, which is as low as you can go. And that's going to give you even lower, way down to 3. So you can see how the correlation coefficient really plays a part in the standard deviation of the combined two-asset portfolio. Okay, so you want to make sure that you enter your percentages down here in as a decimal, and they will convert to percentages. I've got it where we'll do that. So say you put in 0.8 here. Whoops, no, 0.8. Wow, can't type 0.8. Then that's going to convert to 80%. And so the returns that you need to put here are given to you in the problem right here. So you have those, and you have the standard deviations, and you have the correlation coefficient of 0.6. So you should have everything you need here to find the correct answer for the problem. So that is problem 7-9.